name's Fenn. I am Chief Innovation Officer at ITRenew, and ITRenew is a global provider of circular data center services. So we work with really connecting very large hyperscale and large-scale data center operators upstream, and then global markets downstream, and trying to move the whole industry towards a more circular economic model that maximizes both financial returns for all constituents and sustainability.
Now, I've listened to you present a couple of times now, and I know you've got a lot of passion for this, what you do, and you've studied the market quite a lot, and there's quite a lot of data that you've got that underpins the business model that ITRenew have got. Could you just take us through some of the high-level findings from a data perspective?
Sure. So we, the industry in general has spent a lot of time over the last 10 years focusing on operational efficiency in the form of PUE, driving to renewables and so forth. And while there's still a lot of work to do there, our question is, well, wait a minute, IT hardware is the most significant portion of TCO. It's also the most significant portion of embodied energy and carbon impact as compared to the data center infrastructure. So let's try to quantify it and then drive meaningful change on the back of data. So we did a full life cycle analysis of everything from what happens from mining to component manufacture to use phase to end of life, sorting, shredding, smelting, with an eye towards looking at where is the next best place to look after, is operational phase where we need to be focused, or are there other big places that we could turn knobs in a meaningful way? And it turns out, obviously grid mix affects the analysis significantly, but it turns out if you look at a data center, for example in Sweden, that about 3/4, 75% of the total CO2 equivalent impact of IT equipment that's being run in data centers happens before you ever turn it on in a data center. So all manufacturing pre-use phase. In a place like Quebec, where there's a great grid mix, it's more like 95%, right? So it's clearly the next big place to look.
Yeah, and I think it's quite interesting because I've done thinking about kind of embedded carbon, right, and reporting on embedded carbon, and like the automobile industry having to report on embedded carbon, and it hasn't hit our industry yet, but it's certainly something that could potentially come, right? So can you just give me a few stats on kind of the wastage that you saw from a kind of a server hardware perspective, and how extending the life of hardware can impact that?
Absolutely. So if with embodied being such a significant component of overall, if you move from a circular economic model, from a linear model to a circular model, what you're doing is deferring new manufacturing, right? So you're deferring that significant component of embodied energy. And it's important, right? We are, as an industry, we're on a collective track to the wrong direction, right? So we're at currently about 4% as a global tech industry of greenhouse gas emissions globally, and we're on track by some estimates to get to 8%, which is going the wrong direction, right? The rest of the world is, or hopefully, trying to contain GHG, and we are unfortunately being driven by things like AI and all of the streaming and edge and data explosion. We're going the wrong direction, right? At the same time, the waste is immense, right? Nearly 50 million tons of waste annually, which is...
Can we just say that number again? 50 million tons of waste.
50 million
annually.
tons of waste. I mean, to make that visual, 50 million tons of waste is the equivalent of 18-wheel trucks stacked front to back from New York to Bangkok and back every year.
Annually, right?
Annually.
It's just a ridiculous amount, isn't it?
And in the data center space, we have about 50 million servers that are expected to come out of data centers with an average of 50 racks or more over the next 3 years. It's an inordinate amount of waste. Most of that stuff has been run for time frames and lifetimes much shorter than they're designed to run for, and they're going kind of unnaturally early into the waste stream.
Yeah, so because the server refresh cycle has historically been 3 years, right? From that was when we were in an enterprise data center. Yep. So what's the plan?
So the plan is let the major hyperscale operators who do need to refresh things on that kind of a cadence because of the very unique demands of their infrastructure, let them continue to do that, actually facilitate optimization of internal reuse and so forth when we can to help them from the outset, but then make the investments in hardware and software engineering to enable that product to come out of those environments, pristine, perfect, high quality equipment and environments, and then recertify that equipment and give it secondary lifetimes and tertiary lifetimes. And so you go from sort of thinking about lifetimes in 3-year cycles, or even 4 or 5 year cycles, to thinking about them in like 3 + 6 cycles. And so you're deferring significantly the new manufacturing, and you do two things. You enable more value recovery financially for the upstream guys, and you enable very disruptive total cost of ownership and economics for the downstream guys who are constrained by budgets, which most of the world is.
Yeah.
Right?
But do you think it's anti-intuitive for the hardware manufacturers?
It is on the surface, but the experience we've had is actually, and of course it depends who you are, but if you think about, for example, the ODM market, right? These guys, from a business model perspective, are absolutely not set up in a way that, when you're a 2% margin business, you cannot support the global enterprise markets, for example, right? You can only support hyperscale customers who have all of the resources, don't need your support, and so forth, and you deliver them great product. But there's a huge gap in accessibility and usability for the broader markets. So what you have is markets on the downstream side that would like more ODM equipment. The providers of that equipment can't service that market. And what you have is a situation that's poised to be like the certified pre-owned BMW market, which is, you used to have super low-end, lemon used car dealerships and new dealers, and those markets were very, very different people, and there was this big gap in the middle. Whereas now you have a pre-owned, fully warranted, no compromise, high quality, great performance kind of a vehicle that comes out and has expanded the overall pie. So the market didn't shrink, the market got bigger, and the people who are still going to buy new cars, right? And I think we have the same opportunity in this sector, is to meet the needs of the global market that are constrained by giving them access to something that they haven't been able to access.
It's interesting. I hadn't thought about it from an automobile perspective, because it's quite normal for you to buy a new car and then that car to be sold kind of several times over a period of time, and then eventually.
Yep.
So you've extended that. So it's a similar model. You're kind of coming up.
Provided it comes with the right quality, the right warranty, all of those things, right? The right information about it. Exactly. It's exactly the analogy.
I was in the presentation earlier, and we were talking about the BIOS.
Yep.
Is it the BIOS?
Yep.
BIOS. And rewriting the BIOS so that the ownership of the asset is easily transferable. And I think the date that they had for writing that BIOS was 2021, March of 2021.
That's the requirement. The BIOS, which he's referring to, is something called Linux Boot, and that's actually already available. Still work being done on it to make it fully sort of ready for scale and deployment and so forth. But the 2021 date is actually the date at which the Open Compute project is going to require that any OCP certified systems have to come with open source firmware.
Right, okay.
So that will force the industry to, if you want to be OCP certified, you're going to have to support open source firmware, which will make an immense difference in kind of the momentum to get it over the finish line.
But you can do it now. It's not like you have to wait for that.
You don't have to wait, but it's a gate to large, big enterprise kinds of adoption.
So if I'm an operator, or if I'm someone who's looking at my social impact as a business, and I'm prepared to engage in the second user hardware market, how do I go about it?
Contact ITRenew.
Cool. Anywhere in the world? Or?
Anywhere in the world. We are working with public cloud service providers and hosting companies. We're working with private enterprise. We're working with telcos and operators in the developing markets. Truly, because of our global operations and logistics footprint and the fact that we're situated next to every data center environment in the world, we have the ability to decommission that equipment and take it back into market almost anywhere, very readily.
And the economics of it makes sense as well, right?
The economics are generally, people should be thinking about kind of 50% TCO advantage as compared to having to go out and buy proprietary OEM new equipment.
The other point I wanted to cover is kind of the emotional drivers behind this, right? Because you throw numbers out there, but they don't really connect with people. And there's a fear factor of changing what people are doing, right? And there's a fear factor of reliability and, can I get the same support on this? And these are business critical applications. So how do you kind of put that all together?
I think this is exactly what underlies our real kind of ecosystem evangelizing and enablement and engagement, right? Because this absolutely depends on a shared ethos and a mindset change. And so we do a lot of work with our hyperscale partners to have them help us engage with downstream customers and so forth, to help communicate some of the importance of the quality and so forth. But it also comes with real engineering, real data about benchmarks, real data about quality and failures, and getting out there, taking evidence about the quality of stuff, the no compromise and the performance attributes of something into the market through the right channels that can support it at scale, right? So this is not just us acting in a vacuum. It's pulling together all the relevant constituents that give the global markets the comfort that they expect and that they've always expected. But it requires a shift in mindset, right? And fortunately we're seeing, especially in certain parts of the world, we're seeing both a real cultural and a regulatory push in the right direction. So we should have some tailwinds on it, but you're right that it requires a shift in mindset, and I think the best way you do that is by getting lots of people to come together to work on it, but also by doing the engineering that you can do defensible quality and have people be able to see that they're not giving anything up, right? It's not taking a risk.
It's not second best, right?
It's definitely not second best.
And I think the one thing that you said on one of your presentations that really struck home was the deep sea mining. Can you just, as a closing thought process, can you just say that to me?
So the estimates are that sometime in the next roughly 40 years that we will actually run out of the minerals and metals that are required to make electronic components through the sources and countries that we do in mining today. And there are companies that are actively pursuing deep seabed mining as the right answer to this. My proposal is that that's the wrong idea and that we ought to start now, well in advance of that 40-year timeline, to find much more sustainable ways of maximizing the lifetime value of our components and our infrastructure and recapturing those assets, making the system more regenerative and more circular, such that we don't have to start to rape and pillage the deep sea floor as well.
Because you would imagine that as we go on, these things will become, the whole recycling and the whole re-engineering of products is going to develop and change technologically.
Absolutely.
Anyway. So in 10 years' time, we should be able to repurpose things much better than we can now and really create a circular economy.
Absolutely. And that's the goal.
To an extension of life, right?
That's exactly right.
Extension of life is the first phase.
That's right.
And then that moves into a circular economy.
That's exactly right. So this is, admittedly, when you're buying a second life and a third life, the first phase is kicking the can down the road, and we are absolutely doing that. And it's not the end game, but it's an essential piece to buy us time for all of the rest of these things to come online where we can truly move to really regenerative and closed loop kinds of models, right? And we need technology to do that, but if we can buy ourselves an extra 6, 8, 10, 12 years, then that will be helpful.
And are you seeing that technology developing that will kind of create that?
Absolutely. I mean, we're seeing, if you look just in a very isolated way at things like the lithium-ion battery space, the investment in lithium-ion battery processing, recycling processing technology is many billions of dollars just in the US alone, going from kind of like zero to massive overnight, right? So I expect that even in the next 24 months, that landscape will look very, very different. I think we'll see the same thing across components broadly. We're seeing a lot of investment in recovering of rare earth elements from hard drive magnets. Magnets are in every single computing device that is in the world. We have to do that, right?
Okay.
So,
thanks again. Cheers,
thank you.